Hello and welcome. In this video, we are going to bring together everything that we've learnt in the previous two. That is, we are finally going to load in a model and display it. Now this model will be static, there won't be any animation, but it is still a good exercise and it sets us up for future things. So if you check into the linked code, you'll see a few new additions. First up, there's this whole code base, which is just a bare bones OpenGL program. There's also this models folder, and the dependencies folder has changed as well. But anyway, inside this models folder, there's this cube folder, and we've got this, yeah, there we go. We've got this brick texture for a cube. We've got this binary file, which basically holds all the vertex data, and we've got this GLTF file, which describes that data. The task for today is in the, if I go to the source folder and then factories, there's this model factory header and source file. We need to understand this, and in this header we have these headers. Sorry, I said header twice. In this header we have these declarations. We need to go ahead and write the function bodies for those. So it's probably a good idea to take a second and familiarize ourselves with what we've got. There's this static mesh struct, which holds all of these various objects. They're going to need to be populated by the loader. And in order to help us, we've got this vertex struct. This is all the info we need to render a vertex. Its position, texture coordinate, and normal. This video is going to be quite long because there's actually a lot of physical typing. And for that reason, what I'll ask you to do is pause often and have a go yourself at implementing each of these functions. But I've broken it down, and these are roughly the tasks involved in loading the file. And what I'm going to do is I'm actually going to go from bottom to top, because as we get down to the bottom, we get to quite granular functions which just do little things and are quite simple to write, and it will be easier to see how they flow on to the bigger picture. So take a second now to familiarize yourself with the header, and now I'm going to get into it. So I'll grab these declarations, pop over to the source file, and start filling in, give them some stubs basically. So all those stubs are in and we are ready to go. I will mention that the purpose of this video or this series is not strictly to teach OpenGL from first principles. I have many series where I've done that, and so some of this stuff is just going to be given. In particular, for example, describe attributes. So describe attributes is going to create the attribute pointers. It's based on the assumption that the vertex attribute array and vertex buffer array are already bound in memory. And so here's what we need to do. Pretty standard stuff. The position will be a vec3 of floats. Now we're going to have vec3 for floats, vec2 for texture coordinates, that's 5, and then a vec3 for normals, 8 floats, 32 bytes for the stride. The position is an offset of 0. Great. So I'll go ahead and do the texture coordinates and the normals. Great, that's all there. So, one item down. Now the stage before that is building the buffers, and what I mean by this is building the vertex array object, buffer object, and element object. There we have it. So, like I said, I'm not going into heaps of detail on the OpenGL stuff. I'm assuming that we're already familiar with that, but here it is. So we need to fill in the various objects of the mesh. This next function up above might seem a little strange. Build vertices? Why do we need that? Well, if we look back at the header, the way this data is laid out in the binary file, we have all the positions in one region and all the texture coordinates in another region and so on. And so probably the best way to read it is to read all the positions and all the texture coordinates, etc., into these various vectors. But then what I want to do is I want to interleave those attributes because I'm making the assumption that I have the same number of positions, texture coordinates, normals, and so on. If I was somehow referring to different, like I just had a fixed number of normals and I was reusing them for a number of different vertices, then it would be beneficial to have separate buffers. However, with this memory access that I'm doing, it's probably best to interleave those buffers together. So long story short, I'm zipping all this stuff into a single vector. So having said that, this shouldn't be too bad. In this case, I know off the top of my head that I'm going to have 24 of each of these things. So I just need to run a loop from 0 to 24, build a vertex, populate it with the appropriate data, and then throw that into the vertices. Okay, there we have it. This next function is a fair amount of typing. So what I want to do is I want to load a material. If I look in the models folder and then the cube folder, I've got this brick.jpg file here. And if I look at the GLTF data, bring this over to the side, it'll be useful. Inside, if we go from the root of the file down to the images child, and then inside there, we have down here this URI. So what I need to do is I need to use that information and build a file path to that brick file. Might seem a little strange right now, but let me do this. So we'll make basically a string builder, and I will start filling this in. So we will throw the models folder, and then inside the models folder, we could have a whole bunch of folders, but this folder is referenced by go off to the side. Oh, whoops, wrong one. This folder is referenced by the object name. So we can throw that object name in there, and then we want to, look in that folder. And then I want to go models, cube, and then brick.jpg. In order to get that brick.jpg, I need to access this URI. So at this point, I'm going to start using the JSON information. So this GLTF is the root of the whole folder, the whole file, sorry. And then I'll look inside there, I'll look at images, and there's only one image, so I'll just get index 0. And then inside there, I want to look at the URI, and I'll just cast that to a string. So that's fine for now, I'll just close that down. And now at this point, we're going to do the typical load the image, create a material, and all of that. So I've just forgotten to do this. Why can I not speak? I've just forgotten to do this. What I'm going to need to do is include stb image, so I can do that stuff. And on with the show. So this has just done the regular stuff of actually loading all of that in. And we can free that image in the end. But for now, in between then, we're going to do the OpenGL work of making the texture, setting up the sampler, and loading the actual image data. And there is a fair bit of typing, so I'm actually going to copy this, but I know how annoying it is when things just get copied, so I'm going to talk through it. So we go through the usual stuff of making an OpenGL texture, bind it ready to go. Then I'm going to set the parameters of the sampler, the wrapping mode, the filters for minifying and magnifying, all the standard stuff we should be familiar with. Then I'm going to declare a storage allocation, an immutable storage allocation for the texture, and I'm going to then fill that allocation with the data that I loaded. Okay, so that's probably one of the bigger functions. See, it's all coming together. Okay, so what do we need to do now? We need to fetch, basically make these general functions to fetch data from the binary file. And it might be a little easier actually to work on these ones first. Okay, let's go read GLTF file. This should be pretty similar to the first video in the series. Let's do it. And just a note, due to RAII, this file will actually close itself, or at least it should. But I like pairing an open with a close. Doesn't it just look nice? Anyway, so there we have it. We open the file, we read it off into that JSON value, return it. Okay, all good. So now, let's put this into action. Let's read a binary file. There we go. Perfect. So this is really just a copy paste of the previous video. Okay, great. So we've put this off long enough. Let's start writing these read operations. Now, so to give this context, I'll just open up the GLTF file again. And the reason I've got these separate vec3 and vec2 functions is just because I didn't want to muck around with generic types at this point, because then there's one way to do it or another way. I chose this way. That's it. Sometimes making things less general can make them easier. Now note here, what I want to do, this is a bit funky, is I want to step from the root of the file into meshes, and then there's only going to be one mesh. That's an assumption that I'm making. And that mesh has primitives which are like submeshes, and there's only one of those, another assumption that I'm making. But then see here we have position, normal, text coord 0. They're all in attributes, and indices actually is in a different location. So that's why I've written this fetch indices function separate to the other ones. But anyway, let's get into it. Okay, so again, we look at the meshes, we look at mesh index 0, we look at its primitives, and we look at primitive index 0, then we look within there at its attributes, and at this point, I'm just going to take the attribute name and plug that in there, and cast it to an integer. So again, just to give it context, this will be some number like 0, 1, or 2. This is a particularly egregious access pattern, but yeah, we'll see. Okay, so these indices refer to axes, which are here, and then these accesses refer to, well, there's sort of two things that I am interested, or maybe three. Yeah, three things. Sorry, I just zoned out for a second there. I'll walk that back. There are two things that I'm interested in. That is the index of the associated buffer view and the count, so the number of elements. Because I sort of will know that these things are vec3, so I don't need to access the type. Anyway, so let's get the buffer view. So you should be able to skim through this and see how I've accessed the appropriate data. The next bit is the count. And once we know the count, the number of elements we're going to load, we can go ahead and resize the vector to fit that number of elements. Now, if I go down to the buffer view, it's okay. I mean, again, a number of assumptions I'm making. One assumption I'm making is that, again, I'm only going to have one binary file. If that changes in future, I can always adapt to it. But in particular, it's this buffer view that I'm really interested in. And there are two bits that I'm really into, the byte length and the byte offset. So I'm going to fetch both of those. With that all set up, we're so close to done. I just need to mem copy into the destination. I'll be using the similar technique to the video previous. And there we have it. Now we can go ahead and do the same thing for the vec2 case. Again, it's really the same thing. No need to change there. The one which does change is fetch indices. So now we don't have an attribute name. We can actually hard code that. So if I step through this, we have meshes, mesh 0, primitives, primitive 0, and then directly inside there, indices. The rest of this is fine up to destination because now I do not have a general vector that I'm writing into. I'm writing into my indices vector. So everywhere where destination comes up, I can replace that with indices. I think that's fine. I think we're good. So now I can just close that down. And the only thing left to do is finally build the mesh. It's all coming together. So I'm going to need to build some file names and things. So I'll go ahead and declare the structures I'll need for that. So what I'll do is I will look inside the models folder, and then I will look at the given object. And then the convention is it will be always the object name.gltf. Okay, so that's basically grabbing the JSON file. Go ahead and do the same for the binary file. I'm then going to look through the binary file and fetch the various attributes. So I'll close this again in a second, but if we look down here at the attribute names, we have position, normal, and text coords 0, all in block capitals. Done. Those will all be loaded. Now I guess I'll load the material. Why not? Good idea. Then I'll stitch all of that data together into the vertices vector. Then I'll go ahead and build the buffers for the mesh. And I will describe, basically build the attribute pointers. Okay, so the rest of this program has been set up for me, by me, ahead of time, so that if I've done all of these functions correctly, the model will be loaded and it will be displayed on the screen. Fingers crossed. Actually, you know what? Before we do that, probably a good idea to just run through this. So I'll just run this in debug mode. Okay, cool. Let's start stepping through this. So I'll just step over this stuff. All right, here we are. Now, when I click over this, we should get the vertices filling up. So I just go step over. Nice, we've got some vertex data. 24 positions. And now 24 normals, excellent. And then 24 texture coordinates. Okay, I'm happy with that. Now we'll go ahead and load material. Now if we watch this mesh object, this mesh object's material should get reset. Currently this is all uninitialized memory. Okay, great. So we're using material 1 for the mesh. And now if we go build vertices, well, not much is going to happen there. And then build buffers. Nice, look at that. So we've set the element count and the buffers appropriately. Okay, I'm pretty happy with that. I think that function is probably working. Let's now give it a spin. Uh-oh. Okay, what a thing. Okay, so we've got an error here, must write to GL position. Now, if we look at the shader, it's probably good that I put this error in here. It's a good test. If we look at the shader, we in fact are writing to GL position. So what is the deal? Well, this is probably because I ported this code over from a different workflow and the files weren't set correctly. So if I go to app, and this will be fixed, by the way, in the final one, but in the GitHub repo, this will be fixed. But I think if I just get rid of that, I must have forgotten. Okay, so what I've done here is I've just flipped the Z-axis to put this out in front of the camera, not behind the camera. There we go. Perfect. So those little tweaks will be there in the GitHub repo. But anyway, they weren't really the focus of today. The focus of today was loading a model, which we can now see we have loaded. So not sure what else to say. So there we have it. This pulls together everything we've been learning so far. We've read a GLTF file, we've read a binary file, we've used those together to load a static model with no animation. So in the next video, we are going to play around with arbitrary mesh rotation, that is, rotating a mesh around an arbitrary point. I hope to see you again, but until then, have fun. All right, see ya, bye.